So if I go to x1 and then move along the direction of x2 minus x1, I go to x2, right? x1 cancels and I go. But I should not travel a distance equal to norm of x2 minus x1. I should go by something smaller than that, right? So this point will be, I should move in the direction of x2 minus x1, but not totally. I should go by a fraction of distance, right? Let me use the fraction lambda. So what is this lambda? Any number between 0 and 1. If I say 0, I'll stop at x1. If I say 1, I'll stop at x2. If I take something between 0 and 1, I'll be on this line. Do you agree? So what do you think is this line now? This point, I have to add x1 also, right? I have to go to x1 and then move in the direction of x2 minus x1 by a fraction of a distance, right? So how do I write this? How do I write this? So I can write this as follows, right? So I have lambda x2 plus 1 minus lambda x1, right? Algebraic manipulation. I have done nothing fancy here, okay? I've taken out x1 common. I'll get 1 minus lambda out and then lambda times x2. Or I can also write lambda x1 plus 1 minus lambda x2, right? It doesn't matter, okay? So now this leads to the definition, right? So a line connecting two points x, y belonging to Rn is defined as, how do I write this? It is all those points, I'll lambda x plus 1 minus lambda y such that I vary lambda, right? So lambda belongs to 0, 1. So this gives me the line, okay? And this defines all the points on the line. That's all. Now, how do you define convex sets? You take any 2 points in the convex set and you draw a line, or any points on the line should belong to the set, right? That's easy. So how do you write that? This is important. Convex set. A set, I'll take a set C, which is a subset of Rn, okay, in general. Whatever I have shown previously, for example, this and this is not a convex function, the convex set. This is a convex set, so I've written it on a plane, so it's a subset of R2, right? And in general, I can take a subset of Rn, right? Is said to be a convex set if you take any 2 points, right? If for every xy belonging to set C implies lambda x plus 1 minus lambda y, right? For a fixed lambda, this gives me a point on the line joining between the 2 points x and y, right? This should also belong to C. For all lambda in 0 and 1. Right? That's all. I mean, you just convert your geometry into math, that will give you this definition, right? So let's look at a few examples, right? So now I have to look at a few examples, otherwise it doesn't make sense. Now let's look at a ball in Rn. So do you think a sphere in Rn or a ball in Rn is a convex set? Yes, right? You take any 2 points, yeah. Does it matter which ball you pick? When I say which ball, ball is defined as what? I should use norm to define ball, right? If you use 2 norm, I'll get the usual ball. But if I use some other norm, I'll get different shapes, right? Do you think it depends on the norm that I pick? Huh? No. Why? Okay, so we'll see, right? So let's say ball at 0 and radius r, which is defined as all the points x in Rn such that norm of x, I'm not specifying any norm here, it can be any norm in Rn, right, is less than or equal to r. For example, if you pick one norm, you will get this kind of a shape, right? So you won't get a circle. If you take two norm, then you get a usual is convex. So how do you prove that? You take 2 points, right? Take x, y belonging to. Let's see if we can prove this easily. You take these 2 points. Now I have to draw a line joining between this. So what does this imply? This implies norm of x is less than or equal to r. Norm of y is less than or equal to r. That's what this set says, right? The moment you say it belongs to this, it's within r distance from the origin. Now, what is it that I have to prove? I have to prove that all the points on the line, right, belong to this set. So let's look at this. Lambda x plus 1 minus lambda y belongs to this ball, right? Is the question, right? We need to answer this. So when do you say that it belongs to the ball? If the norm of that is less than or equal to r, right? That's what we have to verify. So we'll verify that lambda x plus 1 minus lambda y norm, any norm. I have to show that this is less than or equal to r. So how do I show that? How should we show that this is less than or equal to r? Huh? Sorry? Triangular inequality, because it's true for any norm, right? I need not worry about which norm. So I'll have norm of x plus y is less than or equal to norm of x plus norm of y. Okay. Remember, lambda is a scalar and x is a vector. Plus. So what is the next step? Norm of lambda x is what? Huh? I can write this as, can I do that all the time? Huh? Norm of alpha x is mod of alpha times norm of x, right? It scales by alpha. So do I need mod lambda? No, because lambda is, yeah, it's between 0 and 1. So this is lambda norm of x plus 1 minus lambda norm of y. Okay, what is the next step? I know that x belongs to the ball, y belongs to the ball. What does that imply? This, right? Norm of x is less than or equal to r and norm of y is less than or equal to r, right? So lambda times, I'll replace norm of x by r plus 1 minus lambda times norm of this, which is equal to r, right? So this is triangle inequality, right? And this is as usual. So the rest follows. Is that fine? So it doesn't matter which ball you pick, it corresponds to a convex set. Okay. Anything else? Anything else? Okay. So there are many other sets which correspond to which gives us a convex set. We will see many more such sets as we move forward. Okay. Now let me give you one more example, but this is definitely convex, but it is much more than convex. Let's look at this. What is this? You remember the symbol? What is this? Huh? Set of all n cross n symmetric positive definite matrices, right? Yeah. So is convex. Is it convex? How do you prove that? So take two, of course I have to take 2 points in the set. Now points correspond to matrices. So you take A and B belonging to S plus plus N. Okay. Right? So this implies what? This implies A is A transpose, B is B transpose, and A, B both are positive definite, right? This is what it implies. Now I have to take a line, right? So what do you mean by line here?